This chapter is mainly focused on estimating the impact of fiscal policy. In chapter 5, we learned that whenever the economy is not in long run equilibrium, which means that when the economy is experiencing either a recessionary gap or an expansionary gap, the government can take measures in order to steer the economy back to equilibrium. And we said that one of the methods that the government can use is fiscal policy, which essentially is the use of government spending or taxes in order to affect the economy. So, in this chapter, we know, for example, that when there's a recessionary gap, the government will try to implement an expansionary fiscal policy, or if there's an expansionary gap, the government will try to implement a contractionary fiscal policy, right? This is something that we know. But in this chapter, we'll try to go into details and we'll try to understand. Let's say, for example, that we have an expansionary gap of $2 trillion and the government wants to increase spending in order to close that gap. The question is, for a recessionary gap of $2 trillion, by how much should the government increase spending in order to close that gap? So it's very important to know the numbers, because if the government doesn't do enough, then the expansionary gap will, the recessionary gap, would persist. Or if the government does too much, then another problem will be created, right? So from a recessionary gap, we will go to an expansionary gap instead, right? So it's important to have good estimates of how much the government should do with fiscal policy in order to close a given gap. Also, the first part of the chapter is all about, the technicalities of how we arrive at some formulas. And it's very important to understand how these things function, because we're going to be making use of, a little bit of algebra and a little bit of geometry to illustrate. But then all this is going to be used later in this chapter when we actually use the conclusions of everything I'm going to show you right now to solve actual problems at the macroeconomy level. All right, so this was the introduction. This is what we're going to be talking about. And in the first part, let's talk about the consumption function. But before that, let's go back to high school very quickly and talk about what an equation is, and especially the equation of a line, of a straight line. I'm pretty sure that you are, more or less familiar with this kind of function. Y is equal to a plus bx. So basically, this is a function because it shows you the relationship that exists between a variable called y, okay, that we represent on the vertical axis here, and another variable called x, which we represent on the horizontal axis. A and b are specific values of the function that we also call parameters. Okay, oops. All right. Now, this value here is a special value in this function that we call the intercept, because this is the value that y has, okay, when x is equal to 0. So try to visualize it. When x is equal to 0, this term here goes away, okay, and then y is equal to a. And graphically speaking, this is the value where the function, when it is drawn, touches, if you will, the vertical axis, okay? And this is known as the y-intercept, the intercept, okay? Intercept, like this, okay? Now, b is also a very important value, and it is actually known as the slope of the line. And the slope of the line is nothing but the rate at which the value of y changes when x changes by 1 every time. So what do I mean by that? Now let's assume that at this point here, x is equal to 1. And x changes by 1. X increases by 1. Okay? So from 1 to 2. Okay, so x has increased by 1. And the question is, okay, when x increases by 1, by how much does y change? Okay, if we stay on the function. All right, so because we don't really have real values here, I'm going to call this value here y1, and I'm going to call this value here y2. So we want to know what's the difference between these two values. Well, the answer is the slope. The slope is b. Okay, so y has increased by b when x increases by 1. Now, to give you an example that is in a specific context, let's say that we're looking at wage, okay, is equal to I don't need to do that, but I'm going to explicitly say 0 plus 725 and then hour. Okay, now this here is the wage equation for someone earning minimum wage in the United States. So if you want to know what the wage is, it is equal to 0 plus 725, which is currently minimum wage in most states, I believe, times the number of hours, that the specific worker worked. Okay. All right. So let's try to do this. Now, it's not going to be exact. I'm sorry. I'm trying to use different color here. Okay. All right. It's not going to be exact, but on this axis, we have wage. Okay. And here we have hour. So this is a function which basically tells you, okay, if you have a given number of hours, you can just plug it in this function and then you'll find what the wage is. Okay, so if someone has 12 hours, we just plug it in here. Someone has 25 hours, we just plug it in here and we'll know the person's wage, right? Okay, now the intercept, remember we said that this is where the line touches the y-axis. Okay, the value where the line touches, the line that we're going to draw, touches the y-axis. And this value happens to be 0. Okay, and we also said, and 0 is right here, right? We also said that this is the value of wage when hour is equal to 0. And it makes sense. So if you haven't worked at all, in other words, hour is equal to 0, then your wage is also 0. Okay, so this is a line that is going to start here. Okay, and I sound like a broken record now by saying that it's not going to be exact. Okay, but this is the line that represents this equation here. Wage is equal to 0 plus 7.25 hour. Okay. Okay, so now let's try to interpret the slope. What does the slope mean? Remember, I told you that this is the value. So if hour increases by 1, you want to find out by how much wage will increase. Well, it will increase by 7.25, and that's the slope. So if someone has 1 hour, if you plug it in the function, how much is the person going to get? Well, 7.25. Okay, so that's if you plug 1 here. Now, if the hour increases by 1, you want to find out now by how much wage will increase. Well, it's going to be 14.50. Okay, so you see that increasing hour by 1 increased, okay, wage by 7.25, and this is the slope. Now let's try it again. Let's increase hour by 1 again. Okay, if you plug 3 in that function there, okay, you get 21.75. So you see, increasing hour by 1 increased wage by 7.25. Well, I believe you understand at this point. This is what we call the slope. And usually in math textbooks, it is represented like this. You know, they will draw something like that. Okay. And then they will write the name of the slope here, or the value of the slope. Or if it is a variable, this is how they do it. Okay. Now, we did it in a very generic way here, so we'll just say that the slope is like this, and that's b, basically. Now, this is important to understand because we're going to use that right now in another context, and that's the context of consumption. Okay. Now, back to the notes. The consumption function is, it strangely looks like that function that with y and x that we just talked about, or the wage function. We have C is equal to A plus MPC. Now MPC is a single value, okay? That's one value here. It's not three values like M times P times C. No. It stands for marginal propensity to consume, and we'll talk about it in a second, okay? So MPCYD. Now let me rewrite this very quickly, and let's see the parallel, okay? All right, so Y is equal to A plus BX, and we have C is equal to A plus MPC, and then we have another value here, YD. So you see there are strong parallels here, okay? So Y corresponds to C, okay? So that's how much the entire country consumes. We also have an intercept. Well, the intercept has the same name, but you can really call it whatever you want. The letter here is not really the most important, but there is an intercept. And the slope in our case here is MPC, okay? And the variable on the y-axis, on the x-axis, sorry, is a variable that we call YD. So what do these mean? Okay, this is consumption. The A here stands for and MPC is the marginal propensity to consume. Okay, actually, maybe going back to the notes is going to be much better. Okay, so C is consumption, how much is consumed overall in the entire economy. A is autonomous consumption. Okay, so once again, the intercept, remember, we said it has a very important interpretation. So, oops, I am sorry. Okay, so this simply means that this is how much people consume even if YD is 0. We don't even know what YD is yet, but when we get to that, we'll come back to the interpretation of A. MPC is the marginal propensity to consume, so it is the slope, okay, of our consumption function, and YD is disposable income. Okay, so let's explain all this. We know what the income is, okay? Your income, let's say you sign a job contract and you're told on the job contract that you're going to make, I don't know, 70K per year, okay? Well, the thing is, if you divide 70K by 12, the value that you obtain is not exactly what gets sent to your debit account at the end of every month. The reason for it is because taxes have to be taken out of your income. All right, so disposable income is actually your income minus taxes, okay? And real income is Y and T is taxes. So that difference is what the variable here is, disposable income. All right, so now that we understand what YD is, we can then go back to A and interpret it. So A here just represents how much is being consumed in the entire economy, even if you have no income, basically. You have no disposable income, there's no work, no income at all. Okay, this is how much is being consumed. And this is actually true at many levels. Even if, there's no income, there are sources for consumption, and it depends on many things. And we're not going to look at what I'm going to talk about, but just to put it in perspective, but how much you consume when you have no income could be past savings. Okay, past savings. So you have income 0, but you can still consume. At the national level, it could be unemployment insurance, so like all sorts of transfer payments, welfare, So A depends on all that. So how much the economy consumes, even though there is no income. All right, the MPC, marginal propensity to consume, is the percentage, okay, the percentage of the disposable income that is consumed. Okay, generally, your disposable income, there are two things that people do with the disposable income. They consume and they save. So that percentage that goes to consumption is what MPC is. This is the reason why it is generally between 0 and 1, okay, just to represent it as a fraction. So if it is 0.7, it means that 70% of disposable income is consumed, and of course 30% is saved. If it is 0.9, then 90% of disposable income is consumed and only 10% is saved. Okay. All right. So when we expand this definition, for YD, when we include it, then what we get is consumption is equal to disposable income plus marginal propensity to consume times YD, which essentially is Y minus T. Okay, now what I do here is I try to just draw that line again, that function, but now this time using the consumption function. So A is the intercept. So even if disposable income is 0, this is how much people are going to consume. Now the rate at which this line increases, in other words, the slope is the marginal propensity to consume. Okay, it's the marginal propensity to consume. And as I told you earlier, it is between 0 and 1. Okay, and of course, on this x-axis, we have disposable income, which is Y minus T. All right, so this is really what the consumption function is. Now let's try to go a little further. Okay, I will have to switch to this for a second. Okay, now going back to our line here, see, if for some reason your intercept changes, okay, if your intercept changes, it will actually affect the line overall. It will shift the line up or down. So what I mean is, if A increases, okay, well, it means that the point where the line touches the y-axis is not going to be here anymore, right? It will have to be somewhere else. So whatever it is, that's where the line is going to touch the y-axis. The red line is going to touch the y-axis. Okay, if it is lower, then it's going to shift down, okay, the line, and then this is going to be our new line. But if it is higher, then this is going to be here, right? So this is the impact of a change in the intercept on a function, okay, especially a straight line. If the intercept changes, it will shift the line up and down. And that's what I was trying to explain here. Let's assume that this used to be a consumption function, and now we have a new autonomous consumption such that A1 increases to A2. So you see we had A1 here, and because A2 is higher, that increase in the intercept is going to cause the line to shift up. Okay, it's really important to understand that. Now, of course, let's not just bury your face into math only, but let's try to understand, what could cause that. Basically, so let's say that the government decides to offer more welfare, or higher unemployment insurance, or people have had a lot of savings and over the past few years of economic expansion. So when all these things happen in the economy, it actually increases also the autonomous consumption component of the consumption function. Okay, and basically to interpret this shift up, it means that people now consume more. Okay, they consume more because you see we have consumption on this axis, and because this line is on a higher level, it means that people have access to higher consumption. All right, so you could see this as maybe the consumption function of the United States in the 1800s, and this is the consumption function of the United States in in the 21st century, basically. So the consumption levels have increased overall. Okay. All right, so it's important to understand because we're going to get back to that. All right, so besides the change in the intercept, we can also talk about a change in the slope. So if the slope changes, what's going to happen? Now, it's important to know that when a slope is higher, especially in absolute value, it means that the line is steeper, okay? But when the slope is lower in absolute value, it means that the line is flatter, okay? So C2 would be a consumption function with a relatively higher slope, a relatively higher marginal propensity to consume, okay? And C1 would be a consumption function with a relatively lower marginal propensity to consume. Okay, so again, if we go back to this, that would be a change in B. If B goes up, okay, in absolute value, then it's not like the line is going to shift. The line is not going to shift at all. It's going to stay on the same intercept, but then become flatter. It will rotate if you want. It will tilt. It's going to become steeper or flatter. All right, and that's exactly what I'm doing here. You see, no change in the intercept here, but change in the slope instead. And we still have C for consumption and disposable income on the x-axis. Okay, so this is basic, basic things in functions generally. So it's not really a problem. Okay, now there's a little thing that we're going to do here, and I'm going to take you through this in a second. So what we've done so far, and actually let me go ahead and do it right away. So what we've been doing so far is we've been expressing C as a function of disposable income. All right. So implicitly, this is what we've been doing. We've been expressing C as a function of disposable income. But you see, in order to be true to ourselves, because disposable income, data on disposable income is fairly difficult to obtain. But data on income is much easier to obtain. So if you ask me what's my disposable income per year, I wouldn't be able to tell you. The value I would be able to tell you is what is on my job contract, right? That I know, right? So what we want is basically C as a function of Y. That's what we want, okay? So what we are going to do then is we're going to try to transform this equation here, C as a function of YD, to an equation that is more in line with this, C as a function of Y. So how do we do this? It's actually fairly simple. So C is equal to A plus MPC, and we know that YD is Y minus T. So there it is. We can actually pull out the Y from this expression here. So that would be C is equal to A plus MPCY minus MPCT. Okay? All right, so I want Y on my x-axis now, which is real income, okay? And C is going to stay on my y-axis. So let me just rearrange these terms. I'm not going to change anything. I'm just going to rearrange. I'm going to put A minus MPCT on one side plus MPCY, MPC times Y, on the other side. So in this function, what we get essentially is this right here, A minus MPCT. This becomes the intercept of our function, okay? And this is still the slope of our function. But now, what we have here is what we're looking for, Y. Remember this, it's much easier to work with Y instead of working with YD. Okay, so this is another way of interpreting of looking at the consumption function. It is still the consumption function, but now as a function of Y instead of YD. And again, this function here is actually equivalent to this function. Okay, just that the expressions or the way consumption is expressed is different, but it is still equivalent. Okay, all right. So let's now try to represent this on an XY coordinate system. I have it in the notes, but I'm going to do this one with you. No, I want the XY axis. Okay, like this. All right, so now I have C, okay, as a function of real income. Okay, now previously, what we had was we had A as an intercept here, and we had a line. Oh no. Oh no. A, okay, and we had a line like this, and this was C is equal to A plus MPC YD. So this is what it looked like. But now that this is the function that we have, the intercept is slightly lower. Okay, the intercept is slightly lower. Because it is A minus positive value, so it's definitely going to be less than that. So we're going to have this is going to be our new intercept, A minus MPC times T. Okay, marginal propensity to consume and taxes. All right, but check, the slope is going to be exactly the same. So these are going to be two parallel lines. Okay, these are going to be two parallel lines. Okay, so this is now C is equal to A minus MPC minus T, all right, which is our slope, plus MPC times Y. Okay, so we are going to spend more time using the blue line, okay, rather than the red line. Okay, the blue line again is C as a function of Y. Okay, and that's exactly what I do here. I haven't really compared it with the old one, and that's why I wanted to do it for you. Because if we were in class, I would have done it. But that's basically what it is. Okay, the slope is exactly the same. All right, that was our discussion on the consumption function. It's very important for everything that is going to follow. So hopefully you were able to understand what we said. Okay, we just used basic functions to express how much the economy consumes depending on the real income of the economy. Okay, number 2, we're going to talk about aggregate expenditure and real GDP. Now, this is a bit of theory. I'm going to read through it and try to explain. But in Econ 201, and sometimes it is taught in 202, you talk about the circular flow model. And this, in the circular flow model, okay, that you study in economic principles, there's an important conclusion that you derive from that model. And that conclusion is that aggregate expenditure is equal to aggregate production, which is equal to aggregate income. All right, so I'm just going to pull up a circular flow diagram and then try to explain it from there. Okay, so this is a diagram that I pulled up from a website called polyconomics.com, and it is a representation of the circular flow diagram. All right, so basically what you have here is firms, businesses, and businesses produce goods and services, televisions, clothes, food, and so on and so forth. They produce goods and services, and these goods and services are sold to households. And by households, we mean you and I, consumers in general. Okay. But how do these firms produce all these goods and services? Well, they require what we call the factors of production. You see, they need to hire people to work for them. They need maybe land, and land belongs for the most part to families and things like that, So they need, factors of production from households in order to produce. Okay, so when they produce and sell the goods and services, they make some form of revenue. See, that's the money in green here. They make money, and this is the money that they use to pay the households for the factors of production they take from them. So it goes full circle, basically. So at the end of the day, what we understand from this chapter, that main conclusion that we were able to derive from this chapter was this. Everything that is produced by firms in monetary values, okay, so that's what I'm talking about is this red arrow on top here, okay, that's aggregate production. This is equal to aggregate expenditure, because if a car costs, I don't know, $9,000, well, households are going to pay $9,000 for it. So the monetary value of everything produced in the economy is equal to, or is equivalent to, I should say, how much money is being spent by households, which kind of makes sense, right? It's equal to how much money is being spent by households. But where does that money come from? It comes from their income here, So all the money that households spend is equal to how much households make in general. So this is why we end up with aggregate production. Okay, what all the businesses produce in monetary value is equal to aggregate spending or aggregate expenditure, and this is equal to aggregate income. Okay, so that's mainly the big takeaway from this model here. Okay, no, wrong. And that's what is written here. Aggregate expenditure is equal to aggregate production is equal to aggregate income. But in this chapter, we're going to focus on aggregate expenditure is equal to aggregate income. And we're just going to represent it like that. AE, aggregate expenditure, is equal to Y, which is aggregate income. This is the main assumption of what is called the Keynesian model. And this here needs to happen for an economy to be in equilibrium, because it's not always equal. But an economy is in equilibrium when everything that is produced is also bought, basically. The economy is in equilibrium when all the money that all economic agents plan to spend is exactly enough to purchase all goods and services produced in the economy in a given year. So that's what equilibrium is. So aggregate expenditure is equal to spending by all economic agents. So that would be households, businesses, government spending, and the international sector. Guys, do you remember this formula here? This is how to calculate GDP using what is called the expenditure approach. And it's nothing but, the calculation of GDP that you learned in Econ 201, which is principles of macroeconomics, by the way. All right, so aggregate expenditure is equal to money spent by households plus money spent by businesses plus money spent by the government plus the money spent in the international sector. So what we're going to do now is we're going to use this function here, okay? And remember that C is something that we are familiar with. Actually, the whole first section of this chapter was about the consumption function, okay? So what we're going to do is we're just going to plug in the consumption function that we derived here, okay? We're going to plug it in here. Of course, the expression is going to be a little messier, but nothing really too difficult. So when we plug it in here, this is what we get. So what you have here is C, okay? And then we have the rest of the function, plus I, G, and X, plus I, G, and X, and this is C. All right, so the only thing that I did to move from this to this, I didn't change anything, I didn't add anything or retract anything, I just rearranged the terms. Because you see, MPCY is something that, that we are familiar with, because this is the last part of the consumption function here. So what I did is that MPCY here, okay, I took it to the end of the expression. That's why you see this at the end of the expression. And everything else, I just put it in parentheses. Okay, so now, even though it looks longer, this is exactly like y is equal to a plus bx. That simple linear function that we talked about at the beginning. It's exactly the same. Just that now we are, expressing aggregate expenditure as a function of real income. That's basically what we're doing here. So all this right here, guys, is the intercept, and that's what I explained here. All this is the intercept now. And we have the slope, which is the MPC once again, and times whatever variable we have on the x-axis. Okay, so this is the intercept, this is the slope, and AE is a function of y. Okay, perfect. And of course, what we're going to do next is we're going to try to represent AE. Okay, we're going to try to represent AE as a function here. Okay, so how do we do this? I'm going to have to rewrite it first. Okay, so aggregate expenditure is equal to, now this is the intercept, A minus MPC times T plus I plus G plus NX. All this is the intercept plus MPCY. Okay, so let's do this. Okay, now AE as a function of y, right? So real income, this is a weird y. My y looks like that very often. So this is the real income. This is aggregate expenditure. Okay, and let's look at the intercept. Nothing different here basically. It's you just pick a point. This is the point where that AE line is going to touch the y-axis here. Okay, so that's going to be A minus MPC T plus I plus G plus NX. Okay, so this is our intercept. And because we know that the marginal propensity to consume is between 0 and 1, so it is positive. Oh, I missed my intercept a little bit. Okay, I hope you will forgive me. Let me see if I can do it. Yeah, sometimes it's not as smooth as I would want to. Yeah, guys, this is the intercept basically. All right, and our slope once again is MPC, like this. All right, and this is the AE line. All right, so AE is a function of y. Or I can rewrite all this here if I want, but AE as a function of y. Okay, now what we're going to do next is remember that our economy is in equilibrium when the the aggregate expenditure is equal to real income. Okay, that's one of the this is the condition for equilibrium according to the Keynesian model. So we need to find out, in our economy's AE function, or aggregate expenditure, which point on this line here corresponds to a point where AE and Y are equal. Well, looking at it just like that, it's going to be very difficult for us to find it. So what we can do is we can try to get the help from another line, which is going to help us find that point. The other line is going to be in green. Now, because we have AE and Y equal, it's going to draw a very special line that we use a lot in math. So if Y is equal to 1, then AE is going to be equal to 1, basically, on this point. Okay? If Y is equal to 2, AE is also equal to 2. So we have this point, and so on and so forth. So we're going to draw a line, okay, that has exactly this equation. A line for which every single point is such that the value of Y and the value of the aggregate expenditure are exactly the same. This line is called the 45 degrees line. Okay, 45 degrees line, in the sense that we know that the angle here measures 90 degrees, and we're going to divide it in two using that line. And when you divide it in two, what you get is 45 degrees. Okay. All right, so this is a line such that AE is equal to Y, like this. Okay. All right, so remember the question that we asked. This is the actual aggregate expenditure line for economy, and we were wondering, okay, where on that line do we achieve equilibrium? Okay, and it was difficult to know, but we also know that all the points on this line here are such that the equilibrium condition is satisfied. So we just need to find the point of intersection between our actual aggregate expenditure function and the line that came as a superhero to help us. Okay, so that's basically it here. This is the point where our actual production point, Y, let me call it Y0 because I don't want it to be the same as the label for the axis, and I'm going to call it AE0. All right, so this is where we achieve equilibrium, and this right here, ladies and gentlemen, is the short run equilibrium GDP. Okay, now this short run equilibrium GDP should ring a bell, okay, especially if you watched the video on the chapter 5. This essentially represents the equilibrium GDP where the aggregate demand and the short run aggregate supply intersect. Okay, so this diagram that I'm going to draw right now really pertains to chapter 5, but I just want to tell you that it's essentially the same. So over there we have the price level and we have real GDP here, right? And we had aggregate demand and short run aggregate supply. Short run aggregate supply. Okay. All right. So we said that where these two lines or these two curves intersect, okay, that's where we have what the economy is actually producing, of course, with the current price level. Okay. So these two Y's here are equivalent. But in this model, okay, we obtain Y by looking at the aggregate expenditure function. Okay, we don't use aggregate demand or short-run aggregate supply to find Y. We use the aggregate expenditure only. Okay, but again, I just wanted you to know that they are equivalent. So there's really no difference. Okay, so now that this has been established, let's move to the third part of this chapter. We're going to talk about fiscal policy and the government spending multiplier. Okay, so what did we say fiscal policy was? We said that fiscal policy is any action taken by the government to either change government spending G or taxes. Okay, changing government spending or changing taxes. According to the Keynesian model, and that's what we've been discussing since we started this chapter, government spending and taxes are components of aggregate expenditures intercept, right? Let's go back to that function again. I can show it to you in my notes. So you see, government spending is right here. I'm actually going to highlight it for you. Okay, this is supposed to be a G. And taxes also are here, right? And this is the reason why we took time to develop this model, because this is a model that captures all the actions that the government takes with respect to fiscal policy. Now, one thing that I want you to see as well, and we're going to read it right now, is the two components are in the intercept of the aggregate expenditure function. So let's say, for example, that the government spending is increased, and this is called an expansionary fiscal policy. Okay, G goes up. If G goes up, because G is part of the intercept, all this will increase. The intercept will increase, therefore the aggregate expenditure line is going to shift up. You see how it works, right? Or if the government decides to increase taxes instead, well, because of the minus symbol here, if taxes increase, then the whole intercept will fall, and then this is going to shift aggregate expenditure down, and there will be consequences, which we'll talk about. All right, so this is just a general idea of what we're going to be discussing. Right, let's go back to the notes and read. Okay, so according to the Keynesian model, government spending and taxes are components of AE's intercept. Therefore, fiscal policy either shifts the AE line up or down. Consequently, the equilibrium output also changes. And I think this is actually easy to see, that if the AE line, that red line, shifts up, then the point of intersection is going to be, on this side, and this will cause the, the short-run equilibrium GDP to increase. Or if the line shifts down, then the new point of intersection will be on this side, and this will cause the short-run equilibrium GDP to decrease. Okay, so I think this is kind of fairly easy to see, right? And that's what I try to exemplify here. So let me go ahead and go back to the notes there and then illustrate it for you. I'm going to try to reproduce this diagram right here. Okay. I can just do it here. Okay, let me just do it on this. Okay, so now the new piece of information is, okay, the government decides that, okay, there's a recessionary gap right now, and they want to increase spending. Okay, they want to increase spending. So what we're going to do now is, you see, this is going to increase. So from G1, this is going to go to G2. And because G2 is higher, we said they increased it, the intercept is going to be on a higher point here. Okay, so now our intercept is going to be A minus MPC T plus G2, such that G1 is less than G2, okay, plus NX. This is our new intercept. The slope hasn't changed one bit, so the two lines will be parallel. So it's just a shift. It's not like it's, pivoting to or something like that. All right, so this is now our second function. Let's call this A2, which is a function of y. Okay. All right, so as you can see, ladies and gentlemen, our new point of intersection is here. All right. And this means that we are now producing a higher level of GDP. Let's call this Y1. And that's what a government would want to do. If there's a recessionary gap, they would try to increase spending in order to increase GDP. Okay, now guys, this here is exactly what we talked about in the previous chapter using the aggregate demand and short run aggregate supply curve. Because we said that when G increases, because remember we said G is a component of AD, right, of aggregate demand. So when G increases, okay, the aggregate demand curve shifts to the right. Let's see. I'm going to do it. Okay, let me just do it in red again. Okay, the aggregate demand shifts to the right. That's an increase in aggregate demand. I'm going to call this AD prime. And when that happens, look, what is happening to Y here? Okay, GDP increases. And of course, our price level increases. So this creates inflation in the economy. But again, what we really want to focus on here is the increase in GDP. So these are two different models that basically tell you the same story. Okay, now don't really mind the fact that this increase here is bigger than this increase. I haven't really drawn this to scale or anything like that or with specific values. This is just to show you that indeed if you increase fiscal policy with an increase in government spending will increase the real GDP here, and it will increase the real GDP here as well. Now, the reason why we're looking at the same effect from a different angle is very simple. Using this model, it's impossible to really do what we set out to do at the beginning of this chapter. We can't really estimate with precision, okay, how much Y is increasing. Okay, it's kind of difficult using this model. But this model is actually very possible to do that, especially because we have functions. So we know exactly what this function is. We have information on every single point on these lines. We also know what this line is. So let's assume that, you see, this increase in government spending here that we talked about from G1 to G2, let's say, for the sake of examples, that the government decided to increase the spending by $100. Okay? So we know for a fact that this shift up here is a shift by 100, okay, plus 100. That is something that we know, right? Okay, now the thing is, the resulting impact on GDP is not going to be 100. The reason why it's not going to be 100 is because, you see, these are lines that are kind of curved. They move up at a certain speed, which is the slope, and then we have different angles. Okay, well, the two angles that I just showed you are equal, but we can use these values here because everything is mathematically determined. We can use these values to find out exactly by how much Y increases here. And this is even using geometry, but with the functions themselves, you can find out what the increase in Y is. All right, and remember, this is exactly what we're trying to do, estimating the impact of fiscal policy. So now what we're going to do is, if we have a recessionary gap, okay, recessionary gap of $500, okay, by how much do you need to change G, for example? Or, in fiscal policy, we use taxes too, or by how much should you change taxes to completely close that gap? Okay, so these are the kind of questions that we're going to answer using the knowledge that we acquired here. But guys, you know what? Let's take a quick look at a different example. So here we decided to increase government spending, but what would happen if the government decided to increase taxes instead? Okay, so let me just draw this diagram very quickly. Okay, so we have aggregate expenditure, we have real GDP, and okay, we have an aggregate demand, aggregate expenditure. I'm going to call it AE1 as a function of Y, and the intercept, as always, A minus NPCT plus I plus G plus NX. So all this is part of the intercept. And there's this line that came to save us that we also need to add to the entire thing. the 45 degrees line, the line for which every single point is such that the values on the y-axis are equal to the values on the x-axis. Okay, so currently in this economy, this is how much we are producing. Of course, I can show you what the value of AE is, but that's not really what we want to focus on here. We want to focus on GDP, but they are equal anyways. Okay. All right. So now I said the fiscal policy that is implemented here is an increase in taxes. Okay. So let's see, because tax is also another component of the intercept. Let's see how taxes here will affect our intercept. So this is MPC for times T. Sorry, I just spoke French, guys. All right, so if T goes up, because of the minus sign here, the whole thing here will go down, right? It will all go down. So we know that the new intercept is going to be lower. Okay, so let's call this T1, and because it changes, so we want to change names. T2 plus I plus G plus NX. All right. And here, taxes have increased. So T1 is actually less than T2. And the reason why the whole thing has gone down is because taxes increase. All right. So we are indeed going to have this new aggregate expenditure line. This is our new aggregate expenditure line. And check this out. You can see that the new point of equilibrium is going to be here. Therefore, okay, our GDP will fall. And this is something that the government would do in an expansionary gap. An expansionary gap means that we are producing more than our potential GDP, so we need to slow things down a little bit. Okay, and maybe you want me to add this here just to show that, you know, we are going down like this. All right, guys. So once again, given the change in T and these functions here, it is actually very possible to estimate exactly, you know, by how much Y decreases here, which again is the goal of this whole thing. Okay, so this blank page here, guys, don't worry about it. It's just me. That was a mistake in me, you know, scanning this for you. Okay, so yeah, this is exactly what I did in the notes for you. So based on that, we are going to, you know, come up with some formulas. And these formulas, ladies and gentlemen, this is why we've looked at all these things so far. We're going to talk about what we call the government spending multiplier. Okay, so I'm going to read something that I just said. In this model, it is possible to estimate how a change in government spending impacts the real GDP. For this purpose, we need to compute the government spending multiplier. And there's going to be tax multiplier too. I just showed you how to do it with taxes. But yeah, I'm just going to combine the two just so that you understand what I mean here. Okay, so for all the kinds of questions that you know that you're going to get, this is how to go about it. Step number one: if the fiscal policy under consideration is a fiscal policy that has to do with the change in government spending, then you calculate the government spending multiplier. How do we do this? 1 over 1 minus MPC. Okay, which is the marginal propensity to consume. This is how to calculate the government spending multiplier. Now, once you get the government spending multiplier, what do you do with it? Well, you now need to use this function. Okay. Change in Y is the impact on the GDP. So that's change, delta Y is change in Y. Okay. This is equal to the government spending multiplier, GM, that we just calculated here, times changes in G. Okay. So guys, this is the miracle equation that we were looking for. So if the government decides to increase spending by 100, okay, then that would mean that the change in G is 100. Okay, if the government decides to decrease spending by 2,000, that would mean that change in G is negative 2,000. That would be a decrease, right? Okay, so if you have the government spending multiplier, you plug it in here, you know by how much the government decides to change spending, you plug it in here, and after multiplication, you will obtain exactly how your total GDP will change, okay, as a result of the government spending multiplier here. Oh, sorry, the government spending multiplier. Oh no, as a result of a change in G here. That's what I meant. Okay, or as a result of this fiscal policy. Now, there's something interesting that we understand from this. The interesting thing that we understand is that the government spending multiplier, okay, you see, the bigger it is, the more impactful fiscal policy through the government spending multiplier is, right? Because if GM is big, then small changes in government spending are going to have a big impact on the GDP, right? And that government spending multiplier also depends on the marginal propensity to consume. Okay. All right. So basically, if the marginal propensity to consume is higher, then the government spending multiplier will be higher. Then changes in government spending are going to have a bigger impact on the real GDP. So basically, let me just rewrite it. Higher marginal propensity to consume leads to higher government spending multiplier, leads to more effective, okay, fiscal policy using changing G. Okay, so what do we understand? So if you are in an economy where people consume a big portion of their income, so it's a consumption economy, then this kind of policy is going to help out a lot. But if you go to economies where people are more saving minded, it's like historically many Asian economies, they have this kind of dynasty mentality, save for my children and for my children's children and so on and so forth. This is what has happened historically. Of course, things are changing all the time, but when you go to places where people are more saving minded, then changing government spending, of course it will have an impact, because at least people consume at least a certain portion of their income, right? It will have an impact, but the effectiveness is not going to be as high as in economies where people consume more of their income. All right, so that's really it for a change in the government spending multiplier. A change in government spending, using the government spending multiplier. But if it is taxes that has changed instead, you can't use this formula. You have to use the tax multiplier, okay, that we'll call TM. And the best way to kind of remember how to go about it is, you see, in the intercept of the aggregate expenditure function, a change in G, okay, will affect the whole intercept, with a 1-to-1 ratio. In other words, if G increases by 10, then the whole intercept will increase by 10. If G decreases by 1,000, then the whole intercept will decrease by 1,000. So because G is for lack of a better term, a free agent. But that's not so much the case of T. If T decreases by 50, the whole intercept is not going to decrease by 50 because negative MPC is attached to it. You see what I mean? So an increase of taxes by 10 is going to affect the entire intercept by 10 times negative MPC, whatever the marginal propensity to consume is in that economy. So we need to take it into account. All right, so let me just rewrite the government spending multiplier. But for the tax multiplier, we need to account for the fact that changes in taxes are affected by negative MPC. So this is why we have it on top here. Just like we had 1 here, we have negative MPC on top. And it's the same thing. So if taxes change in this economy, then the impact on real GDP by a change in tax is equal to TM times change in taxes. Okay, that's basically what you need to do with it. Okay, so guys, that's really what you need to understand about this chapter. But let's finish, of course, with 2 examples, and then I really encourage you guys to take some time and go through the practice questions because they'll be very helpful. All right, let's take a quick look at this. We are in an economy in which the marginal propensity to consume is 0.8. In other words, people consume 80% of their income. Okay, they save 20%. Now, government raises taxes by $10. Okay, if that happens, the question is, how is real GDP affected? Right? Okay, because you know that taxes are used in this economy for fiscal policy, the first thing that you want to do is to compute the tax multiplier. Tax multiplier, because taxes were changed. If government spending was changed, then you would calculate the government spending multiplier. Okay, but let's compute the tax multiplier. Negative 0.8 over 1 minus 0.8, which is negative 4. Now this has an interpretation. The interpretation is for every increase in taxes by $1, the real GDP will decrease by $4. Okay, any increase in taxes by $1 will cause the real GDP to fall by $4. Then we said, okay, the government raises taxes by $10, so we just plug it in that formula that I gave you. It's going to be negative 10 times negative 4, I'm sorry, times 10. So real GDP ends up falling by $40. Okay, if taxes increase by $10. Okay, so that was the first example. Let's look at this other example here. The economy has a recessionary gap of $200. So basically, we are $200 below the potential GDP. The government would like to close the gap through a change in taxes. Okay, change in taxes again. Okay, the government would like to close the gap through a change in taxes. By how much should the government change taxes to close the gap? MPC is 0.75. Okay, so again, we're talking about taxes here. So we need to calculate the tax multiplier first. In this case, we have negative 3. Now, when we get to this formula here, well, basically, you know, what we have is we have the target change in real GDP that we want, because we are $200 below. Okay, we are $200 below our potential GDP. So the goal here is to increase GDP by $200. Okay, so it would be wrong to put minus 200 here because we say recessionary gap. No, the goal is to go, you know, to the opposite direction by increasing GDP by $200. So you plug in 200 here, you know that the tax multiplier is negative 3, and then you can find out by how much taxes need to change in order to close that gap. So the gap is going to be closed if taxes are decreased by $66.67. Okay, so these are examples using the tax multiplier. I have some examples with the government multiplier here, which I skipped for some reason. First example, the marginal propensity to consume in our economy is 0.8. The economy's government is planning to increase spending by 50. So delta G is 50. How will this impact the economy's GDP? Well, now that we know that the government spending or that government spending is going to be used for, for fiscal policy to steer the economy back in equilibrium, the first thing that we do is we compute the government spending multiplier. So 1 over 1 minus MPC, which is 5. So every increase in government spending by $1 will increase GDP by $5. Okay, so then we plug in what we have in the second formula. The government spending multiplier is 5. Then the government is planning to increase G by 50. So real GDP will end up increasing by 250. Okay. Now the second example is ECON 312 land, my dream country, is currently experiencing an expansionary gap. So once again, we are in an expansionary gap, which means that we are $1,000 above our potential GDP, our full employment GDP, and we want to get back to it, right? So by how much should the government change spending to close the gap if we know that the MPC is 0.75? Okay, so we're using government spending here. Therefore, we need to use the government spending multiplier. 1 over 1 minus 0.75, which is 4. Okay, so for any increase in government spending by $1, the real GDP will fall by $4. Okay, and it's just like the last question of taxes. We know that we are $1,000 above our potential GDP. So the goal here is, because you see, we want to close the gap, right? So the goal is to decrease our real GDP by $1,000. If we do that, okay, well, then the gap will be closed. So we can just plug in the values here. Negative 1,000 for change in Y, Then 4 for the government spending multiplier, then we can find how government spending needs to change in order to close that gap, and government spending needs to decrease by $250. All right, ladies and gentlemen, this is what this chapter is all about. Again, take a look at the practice questions. They are very important because the test is going to contain questions very similar to what you have in the practice questions. And hopefully you also understood, the theory that I explained here. It's actually quite important as well. Okay, guys, thank you very much for watching, and take it easy.